O3 Lewis structure or ozone Lewis structure or Lewis dot structure for O3 ozone. At first we have to find out the valence electron for O3. Oxygen is an element of group 6a, that is why it has 6 valence electron. Here we have 3 atoms of oxygen, so we need to multiply by 3. So in O3 we have totally 18 valence electron. This 18 valence electron has 2 tasks at the same time. The first task is to connect these 3 atoms together, and the second task is to satisfy the octet for all the oxygen. So these we need first connect to these 3 oxygen. So to connect these 3 oxygen we have used just 4 valence electron, right? So out of 18 we have used just 4, so 14 valence electron left we have, right? Now these 14 valence electrons will be used to satisfy the octet of outer oxygen atom first. So let us put this oxygen has 2, so it will maximum take 6 valence electron to satisfy its octet, and so we have used 6, and this oxygen also takes 6, so 6 6 12, so 2 valence electron left. So these 2 valence electron will come over the central oxygen atom. So now we have used all the valence electron. Now this oxygen has, the central oxygen has 2 4 6 valence electron. The octet is not completed for the central oxygen atom, but this oxygen, the outer oxygen, 2 4 6 8, this oxygen has 8 valence electron, and this oxygen also has 8 valence electron. So we need to satisfy the octet for central oxygen atom. So we can satisfy the central oxygen atom from this side, from moving this lone pair as bond pair. So we are getting this structure, right? So look, we are getting this structure here. If we move this lone pair as bond pair, then we will getting this structure. And let's say structure A this is, and if we move electron from this side, we'll get this structure, that is here we'll get double bond, right? So now look at this structure. So we can express these are bond pair. We can express bond pair as dash, bond pair as dash, and also here we will express this 2 bond pair as dash dash dash, right? These A and B are the Lewis structure of ozone. That is, sometimes sometimes a molecule can have more than one Lewis structure, and these Lewis structure are called resonance structure, right? This is the limitation of Lewis structure actually. The electron density of O3 is explained more deeply by the molecular orbital theory. However, this Lewis structure is also useful, right? So look, so we are getting this structure and this structure. These are called resonance structure. We can express resonance structure by this double headed arrow, right? So look here, in resonance structure the position of atoms remains the same, but one pair of electrons move overall the molecule. Look, this one pair of molecule can come here and here from make a bond here, and to satisfy the octet, so one lone pair will move to the oxygen of here, right? So we'll get this structure. Again from this structure we'll get this structure, right? Observe this, from here we'll get this structure, from here we'll get this structure actually. So O3 has 2 Lewis structure, right? But experiment shows that the real structure of O3 is not this or this structure. Actually, look, O3 there is neither double bond or single bond, right? In O3 you can say the bond is average of single bond and double bond. Look, in oxygen molecule the length of double bond is 121 picometer, and oxygen single bond is 132 picometer. We get from experiment. But in ozone, oxygen bond is 128 picometer. That is, this bond length is the average of this and this, right? So the real structure of O3 can be explained by molecular orbital theory, right? Actually, the real O3 structure is the resonance hybrid of these two structure, right? So what is the Lewis structure? The Lewis structure of O3 has two Lewis structure, this or this, right? So thank you for viewing this video. Be well.